Hello, I'm Gerard Fisher from RAP, and I'm directing the project at RAP on the development and implementation of buying guidance and specifications for buyers and specifiers of electrical and electronic products in the retail sector. As part of this work, we've developed summaries of different product categories in order to identify where failure modes are occurring and how they can be avoided through specifying components, design, and user guidance best practice. This webinar will focus on electric kettles. After reviewing the project objectives, Paul Goodman of ERA, one of the technical experts who's helped to develop this product summary, will talk through the key highlights of the summary. Finally, I'll conclude the webinar and discuss next steps and where to find further information. Through RAP's Electronic Products Pathfinder Group, industry recognised the need to identify design changes needed to increase the life of selected electrical products by bolstering durability. The end result will be guidance development for technical managers, buyers and suppliers to provide industry standard accessible content. A first step has been to research the most common failure modes within the product summaries, which provide a first step towards the development of more detailed guidance documents. In partnership with the Pathfinder members, we've selected washing machines, fridge freezers, vacuum cleaners, microwave ovens, kettles and televisions for assessment in these product guidance notes. The structure of the summaries is the same for each product and will include an introduction on how to use the document, the short-term failures that may result in a product being returned to you, the long-term failures that prevent it from reaching its long-term life, and then best practice in terms of component specification, design and user instructions. Finally, it will identify the opportunities for lifetime extension. So now for more detail on this product, I'm handing over to our technical expert.
There are several reasons why kettles fail in the short term, and a few examples are included on this slide. For example, they can leak between the sight window and the body. This is caused by incorrect choice of materials, or poor design, or poor manufacturing processes. Plastic spouts on plastic bodies can leak if they're poorly bonded. A kettle can fail to switch off. This is caused by poor design. And that's a variety of different possible causes. Lid failures are fairly common, where the lid either refuses to open or it refuses to stay shut. And this is caused by an unsuitable choice of materials in the mechanism or poor manufacturing processes for the parts. Kettles can be noisy. There are variety of reasons for this. It could be the power rating is high, yes, but it should still not be noisy. But it can be because scale builds up and it's not removed by the user. But more importantly, the shape and texture of the hot plate surface can make a big difference to the noise level. In the longer term, there are different failure mechanisms that can occur. For example, the element can fail, and this can be caused by damage either in the manufacturing process or by the user. It can be caused by corrosion of the parts, scale building up to an excessive amount so that it overheats and burns out, or production faults. Plastic parts can fail, they can crack and break off. This can occur with handles, but other parts as well, and it's caused by poor design, which results in high strain on the plastic parts, so they break off. But it can be made worse if the user cleans the kettles with a very aggressive cleaning chemical that causes cracking. The lid or other parts can fail. It's poor design can cause that, or materials choice. The on-off mechanism is usually fairly reliable, but there are various reasons why they can fail. They should last at least 5 years, even with moderately heavy use, but if there are leaks inside the kettle or the electrical contacts are contaminated during the manufacturing process, they can overheat and burn out and not work. Electrical connections between cordless kettles and the base can fail. In the base, there should be a little device which switches off the power when the kettle is lifted. If that is faulty, there will be arcing between the electric contacts, and that will eventually cause these contacts to burn out, so they won't work. So best practice for specifying kettles involves specification of components, the design, test standards, and providing good user instructions. Now, there are safety standards, but unfortunately there are no endurance standards to specify. There are standards for different materials, different bonding processes like adhesives and switches, but not for all of the parts or processes used in kettles. You can specify EU safety standards, but you can't specify most of the parts for kettles, although you can specify the lifetime that you expect the kettle to last. The design is difficult to specify. The durability is dependent on the type of design of bonds, the materials and the design of the opening mechanism for the lid, and so on. It's quite difficult to specify a design for a kettle without designing every single part. User instructions are quite important for kettles. If they're not scaled when they're used in hard water areas, they will not function properly and they will eventually fail. So descaling instructions are quite important. Aggressive cleaning chemicals with plastics is not necessarily good. They can cause cracks, so it's often good to specify the types of cleaning chemicals to be used. If there's a filter that needs to be cleaned, clearly the instructions need to explain how that should be carried out. To design a kettle for durability or reliability is actually quite difficult. You can't specify the parts. You just have to make sure that the materials that are used and the manufacturing process are correct, and both are important for reliability. What they really require is good engineering design and good engineering production processes, and that can only really be assessed by testing the kettles. So ask the supplier to provide test results to show that they will be reliable and survive the lifetime you expect. The product summaries all include many examples of failure modes, their causes, whether they occur early or late, opportunities to how to resolve those early failures, and how that can be achieved with some of the cost implications. And this slide has two examples. The first one is leaks at the water level window, and this can be caused by the failure of the bond that is between the kettle body and the transparent window. Now, for that bond, you can't use adhesive, they're not suitable because of the high temperature caused by the steam. So the most common practice for plastic to plastic is to use ultrasonic welding. And that requires a suitable joint shape and good welding process control. Windows in metal kettles need a different way of bonding, and they need to be clamped tightly with a suitable watertight gasket. And that watertight gasket must survive big temperature differences from 0, from the cold water, up to 100 degrees of boiling water. Now these failures can occur quite early, but it is solvable by having a good joint shape, using the right sort of polymer for the bond, and the correct welding process. And if you use a gasket, to use the right sort of silicone bond between the metal kettle and the body, and the window. So this can be implemented by the kettle designer following good engineering practices in the factory. But to ensure that they do that, the only way is to look for test results to make sure they will survive that, and also for the factory to introduce good quality control to make sure that the quality is maintained. Leaks from base can occur as well, and this again depends on the design of the kettle and the materials that are used. The polymer seals are often used nowadays in kettles. They have to be pretty robust and designed with the right materials and the right shape to withstand the big temperature changes that occur. Kettles go from almost 0 for cold water up to 100 degrees. So the kettle needs to be tested to make sure that bonding process is going to be reliable over the specified lifetime, whatever you decide that is. The cost should not be significantly high because it's part of the normal design process to ensure the kettle is going to be reliable. Although there are proprietary patented seals that are available. They may be a little bit more expensive, although if your supplier is claiming to use those, make sure they're not providing you with counterfeits.
Thank you. Full product summaries for all products will be available for download from WRAP's website from January 2014. Full guidance documents will be made available by March 2014, and there'll be further engagement on the format of these documents. For further details, please contact WRAP through Claire Ollerenshaw, the project manager, at claire.ollerenshaw@wrap.org.uk. Thank you for listening.